This is lesson 3.8, and we're going to be going over solving using the quadratic formula. So the quadratic formula is essentially a formula that helps you if you can't figure out how to factor. So if you're in a pinch and you don't remember how to factor something and you need to solve that equation to get your two x values, you can use a quadratic formula every single time in order to get those two x values, your two answers. Okay, now reducing radicals is something a little bit separate, but is an addition to the regular curriculum, grade 10 curriculum, that I'd like to teach you as pre-IBs. Okay, it's something that we would normally teach in grade 11, but it's also kind of handy when we're dealing with the quadratic formula. So let's start off with just teaching you the quadratic formula first. This is the formula right here. I'll go through it with you. So the whole purpose of this is to be able to find your x values. So we're going to start off with x equals to. The formula works like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, that is something that you have to memorize. Okay, so what goes into the formula? Well, if you have your trinomial right here, where it's in the correct order, all of the terms are in the right order, as in the very first term should be your x squared. Okay, it has the highest exponent. Your middle term should be your x value, which has an exponent 1, so it's slightly smaller. And then the last term should be your constant. It doesn't have any x values, and it should always equal to 0. If it doesn't, move whatever's over here to the other side and combine it with whatever is on this side so that you get that equals 0. When your quadratic equation is in the right order and it has an equals 0, then what you could do is you can identify your a, your b, and your c. So your a value is the number that is in front of the x squared. Whatever that number is, I don't really care about the x squared, I just care about that number. That number is going to be placed and substituted wherever you see an a in the quadratic formula. Now, the b is the number that's it sounds so congested right now, I can't even say number right, it sounds really weird. But anyways, your b value is the number in front of the x value. I don't really care about x, I just care about the number. That number is going to be placed in wherever you see a b. Just be careful because this will be squared. So if b is a negative number, make sure you put brackets around it and then square it so that the result is a positive always right here. When you take your b value, whatever it meant, like it ends up being, put it right over here and there's a negative in front. So be careful that if b is a negative number, it'll be a negative and then in brackets a negative number right here. So a negative negative, which will result in a positive. Okay. The c value, whatever it is, you're going to put it into brackets and sub it in right here. Okay. Now let me explain this circled plus minus symbol. In lesson 3.6, we had not always, but I mean like a lot of the times, we usually get two answers for our final answers for x. And so by having a positive negative, it allows for us to be able to have two different answers. One where you run through the formula, but you only focus on the positive. So negative b plus square root b squared minus 4ac all over 2a. And another answer where you focus on the minus, negative b minus root b squared minus 4ac all over 2a. So you get two different answers. Alright, so that's the rundown of how to use it. Why don't we actually go through some examples? Actually, you know what? I'm just going to stay right here so that you can see the formula and you can see the question for a little bit. The question says to solve for x, so we should get two answers, remember. And they're asking us, number one, provide the answers as exact answers, no decimals. And then number two, let's practice using approximate answers. When they say roots, they basically mean answers, okay? Or solutions. And that's to 1 decimal place. All right, so our question is 2x squared plus 9x plus 6 equals to 0. So that's very nice. It equals to 0 already, And everything is in the right order with the x squared first, then the x, and then the number that has no x's. So I can easily see my a value, which is 2, my b value, which is 9, and my c value, which is 6. I'm going to plug those numbers into the quadratic formula, and I'm already noticing right now that I actually highlighted the wrong color. I'm sorry. I guess this one should have been the green and this one should have been the pink, but in any case, never mind. So negative b, which is 9, plus or minus, I'm sorry about the, when I took the picture, it didn't really show up very well. That's a plus or minus, square root, make sure your square root sign goes all the way to the end, b squared, so b, which is 9, squared, minus 4 times your a value, that's 2, times your c value, which is 6, all over 2 times a, and again your a value is 2. So I'm just following the formula and I'm plugging in these numbers instead of a, b, and c. Okay, so what do you do from there? You start to simplify until you figure out the answer. So you're going to go negative 9 right there, plus or minus, and then just do bedmass. Exponents first, 9 squared is 81, minus, and this is what I do, 4 times 2, that's 8, times 6, which is 48. So minus 48, all over the denominator 4. Okay, so keep simplifying. Work in the bracket, or the square root, I should say. 81 minus 48 is 33, and that's square rooted. Now, if I actually square root 33, I'm going to get a decimal number. So if they're asking in the question for exact answers, stop right here. Your two answers for x are negative 9 plus root 3 over 4, and your second answer is negative 9 minus square root 33 over 4. You can keep it written just like this, and that is your exact answer because you haven't actually square rooted anything and gotten decimals. Now, if you do want an approximate answer, you are going to have to square root this, and they said to 1 decimal place, which I got as 5.7. I put my approximation dot. So now, why don't we find the final answers simplified? So negative 9 plus 5.7, which you'll see right here, divided by 4, that'll result in the first answer of negative 0.8. Notice that I wrote or. So or, my second answer is negative 9 minus 5.7, see? Divided by the same denominator of 4, which I got negative 3.7. These two are my approximate answers. Alright, so again, this is a type of, like using this formula, you would do so if you couldn't think of two numbers that multiply to 12 and add to 9 and actually factor first. But I'm looking at this question right here, and I think I could factor, like I don't have to rely on the quadratic formula. It looks like a very long process. If we can actually factor, it's a lot faster. So I took a 2 out of everything, put the leftovers into a bracket, and I noticed that actually I could figure out two numbers that multiplied to 25 and added to negative 10, which were negative 5, and I solved to the opposite numbers. This should be my answer. This is much easier than using the quadratic formula, but I can absolutely use a quadratic formula and I would get the same answer. So if I were to use a quadratic formula, everything is in the right order. I take the 2, which is my a value, I'm going to plug it into the formula wherever there should have been an a. I'm going to take negative 20, being very careful of the negative, and put it into my formula wherever there was a b. So the formula started off as negative b. So negative 20. Alright? And then the b squared as well, in brackets, the negative 20. And then the 50 is going to go into my c value. So negative 20 makes a positive 20, plus or minus, and do bedmass. So exponents first, positive 400. This is always going to be a positive because you have brackets around it. Minus 4 times 2 times 50 is 400. All right, so this is going to, all over 4 as a denominator. Now I'm going to work on the inside, which will give me a 0, and when I square root that, the square root of 0 is 0. So my two answers are 20 plus 0, so 20 plus 0, all over 4, which is equal to 5. I'm sorry, this is cutting off just a bit. The other answer is 20 minus 0, see? All over 4, which is still 5. So actually both of those result in the same answer because it also both resulted in the same answer up here. But notice that obviously factoring, if you could do it, which should be your very first choice, quadratic formula will always work, but it's longer. Okay, so I have a third one right here where when I actually plugged in the numbers, I don't remember, I might have cut off part of this, I don't remember the question, but something tells me that it didn't equal to 0, so I moved everything over, and so I think I might have cut that off when I took the picture of my work. But yeah, make sure it equals to 0 first, and then again, you're just plugging your A value into the A's, B value into the B's, and the C value into the C's. And when I noticed I started working on the under the square root stuff, I got a 16 here, and a 4 times 3 times 7, I actually got an 84. When I subtracted those, I got a negative number. Now, if you get a positive number underneath the square root sign, it'll result in two different answers. If you get a 0 under the square root sign, you'll result in two of the same answers. But if you get a negative under there, you can't square root a negative, it's impossible. Or you get imaginary numbers, and so we say there is no solution, and you just stop right there. There's no answer. I can't go any further and actually calculate this. So we stop. Now, this is the part where I'm going to start to teach you about reducing radicals. And so this is what we call a radical. This square root negative 68 is a radical. What's inside is called a radicand. So the negative 68 is the radicand, and then you have the square root sign, which is a radical. You can break up that number inside into whatever multiplies, so the factors of both. In other words, if I have root 20, I can break it up into root 4 times root 5. I can break it up into root 1 times root 20. I can break it up into root 2 times root 10. But there's an ideal set of factors you want to use. You want to use the factors where one of them I can actually square root. So I can't square root the 5. That's why I kept it the way it is. But I can square root the 4, which is a 2. And so this is how we simplify root 20. And if you use your calculator, sometimes what happens is your calculator automatically, anytime it has this answer, will convert it into this answer right away. And so that's how they get it. They're just simplifying radicals. All right? So let's try this again. Root 75 can be split into 2. If you want to write the multiplication symbol in between, you can. You don't have to. If it's not there, you know that it's going to be a multiply. So split the 75 up into two numbers where one of the numbers is the biggest square rootable number. So 25 is square rootable into 5, but you can't square root the 3, so we're just going to leave it. Now, why am I teaching you this when I'm trying to teach you the quadratic formula? Because if in a question, let's say starting like this, you have underneath the square root symbol a root that can be simplified, then what I'd like you to do is try to do that. So let's just walk through this. I moved everything over to one side, so I got a 0. Okay, your A, your B, and your C I plugged into the formula, and I started to work with it, and I got a square root 30. This is my exact answer, but we can still use what we have in order to get an exact answer without actually going to the decimals. So breaking up the root 300 into root 100 times 3, I can then square root the 100, which is 10, and then I can divide everything on the top, every whole number on the top, by 2. So 15 plus or minus 5, don't divide the root 3 by 2 because it's a different entity as a root. You're just going to divide the whole numbers. So you get two answers. one with a plus and one with a minus.